Alright, so I looked ahead and it looks like the Fahrenheit to Celsius thing is going to be in the next couple things. So I'll just go up to that and then go from there. So pointers. Normal pointers in Zig cannot have 0 or null as a value. They follow the syntax star t, where t is the type. Referencing is done with ampersand, and dereferencing is variable dot star. Okay. Is that 3 went down? Pointers cannot have 0 or null as a value. No null pointers. Interesting. And follow the syntax star t, where t is the child type. They can be referenced with ampersand variable and dereferenced with variable dot star. Okay. Pointers. So we are making a variable, passing a reference to it. In here, it takes a pointer, and then it dereferences it, adds 1. So x equals 1, reference, dereference to x plus equals 1 equals 2. So that's going to work. And then, so that's equal to 0. And then this is a pointer to a U8, which is a getting a pointer from an int x, y equals y. So y is a pointer and can't be 0. Since x 5 minus 5 is 0, this is going to fail. So Zig test, Zig guide, index, switch. It's actually not making it that far. Pretty sure it's at the index that it's having issues, so let's just do that. No. What? I got rid of that test. Test command failed. Else unreachable. Okay, let's just do that for now. This command crashed. Why? Naughty pointer. Okay, yeah. Cast causes pointer to be null. So that is as expected. SIG also has const pointers, which cannot be used to modify the referenced data. Referencing a const variable will yield a const pointer. There. Oh wow, that was. Are also const pointers, which cannot be used to modify the reference data. Referencing a const variable yields a const pointer. Pretty standard, makes sense. Pointers. So const x. So this will be immutable. And then you also will not be able to change x. Or yeah, sure. Can't change x here. This is a constant pointer to x because x is a constant. Yeah, okay. Pointer-sized integers. U-size and I-size are given as unsigned and signed integers, which are the same size as pointers. Do I know what that means? No. So, test. Okay, let's go get rid of all of this. Cannot assign, yeah. Error following test crashed. Pointer, naughty pointer. Try this again. 22 passed, 1 failed. Yeah. So that means a size of view size is the same size as a pointer to an unsigned 8. But a signed is the same size as an unsigned? What? That makes less sense. But whatever. I'm sure it will make sense later. Keep track of buffers which don't have compile time known lengths. Many item pointers, they act using the syntax. 34 down. There are a also many item pointers that are used to keep track of buffers with comp time unknown lengths. Follow the syntax of T instead of star T. Okay. It's just a pointer to a buffer, basically. That's fine. Many item pointers are not dereferenceable. But are indexable. Yeah, okay. In this example, we've written a function that can take in a buffer of any length. Notice how a single item pointer to an array of bytes coerces into a many item pointer of bytes. Single item pointer to an array coerces to a many item pointer. Think about what might happen if you pass that function the incorrect byte count the programmer is expected to keep track of, or otherwise know the length of these buffers. It is worth noting that this function is effectively trusting us to pass a valid length. We can convert many item to a single item by either indexing an element and dereferencing that, or by using pointer cast to cast the pointer type. Need to know that. Didn't want to make. Can be converted by indexing and dereferencing an element, or by using pointer cast to cast a pointer type. This is only valid when the buffer has a length of at least 1. Makes sense. Local variable is never mutated, that's fine. Still don't really get that, but double all many pointer. So it takes a buffer that is a pointer to an array, and it takes a count that is a usize, which, if we look at here, is simply the size of a pointer. Okay? and returns void. So var I is equal to 0. So while I is less than byte count, I plus equals 1, buffer I times equals 2. So that's going to go through every element and then times it by 2. I do not know what's going on here. So we have a 100 element buffer array that's equal to the inferred length of a U8 array initialized with 1, and then we're multiplying that by 100, so that will give 100 ones, basically. And then the pointer is a pointer to a 100 byte U8. Like, that's the type. And then we're saying that's a reference to buffer. Checks out. Buffer many pointer is equal to a array pointer of buffer pointer. So we're calling the function with this and the length, which is going to be 100. And then for buffer, we're going to work on byte. We're going to try, we want to see if byte is equal to 2. First element pointer is equal to a U8 pointer referencing the first element of buffer many pointer. And then this is just another way to do that. We're using pointer cast. Is that mentioned here? Yeah. So single item pointer by indexing and dereferencing an element, or by using pointer cast to cast the pointer type. And then we're going to check that these two are the same. I'm just going to go ahead and keep all these things permanently commented for now, just so that the test works. Following test crashed, else unreachable. Okay. 16 up. Pointer from int. "23 passed, 1 failed." So this does... Yeah, okay. I'm still a little unclear on what's going on here, but I'm sure it's fine. Slices. Slices are easier to use safely and more convenient than many item pointers. Good, because I'm going to be honest, they don't really make sense to me. As they store the valid length of the buffer with them, sometimes referred to as fat pointers, double the size of a normal pointer. Interesting. Slices can be thought of. They use the syntax and are easier to use safely and more convenient than many item pointers, as they store the valid length of the buffer with them. Unlike many item pointers, for loops work on slices. In this example, a const slice is used in the total function as it doesn't write to the slices buffer. So that takes a constant slice of U8 and returns the size, or returns something of uSize type. Var sum uSize is equal to 0 for values. So for everything in the array, we're going to operate it on as v sum plus equals v. Fair enough. Return sum. Easy peasy. So we have an array of inferred size. It's a U8. 1, 2, 3, 4, 5. So, and then the slice is 0 to 3. So 0, 1, 2, 3. So that should be, well, it's expecting it to be 6, so I don't think it's inclusive, so it's going to be 1 plus 2 plus 3. And it is. Okay. Wow, that's a table if I ever saw one. When n and m values are both known at comp time, slicing will actually produce a pointer to an array. Not an issue, since it will coerce to a slice. So here we have the same array, inferred type, not type, inferred length of U8, so it will be 5. The slice is 0 to 3. 3 is non-inclusive. So it'll be 0, 1, 2. It'll be 3 elements. And then type of slice is going to be a constant. Yep. When these n and m values are known at comp time, it will produce a pointer to an array. So a pointer to a constant array of U8, size 3. Yes. And then also, if you want to go to the end, just going to make that const so it doesn't get angry, since we're discarding it here. Syntax, 40 down. Kind of slice to the end. So this also works. I'm not sure if that's like the first number is inclusive or not, but if I wanted, say, from here, I could change that to, what is that, 0, 1, 2. And then this would give me 3, 4, 5. I'm pretty sure. Yeah. Okay. Make another program, so that will be this, and then I can go to the calculator that I had a miserable time with yesterday. I don't know how I did so poorly on that. I would like to grab this table. Okay. So dereferenceable, yes, no, no. No, yes, yes, yes. Element count, always 1. Comp time, known. Unknown, and then runtime unknown. Okay. No, no. Yes. Hello? No. Size. Size of view size. What the fuck? Size of view size. Size of view size times 2. So this is a many item. This is array pointer. And this is a slice. Let's see what's going on here. So I love text formatting. It's so fun. Okay. And then there we go. Okay. That is a lot to take in. Let's run the test. Comment contains invalid byte \t. Of course. Let's go. What? +7 trailing characters. Vim %s trailing characters. I had this happen before yesterday too. Never had it happen before. I don't know what it means. Trailing character are in your command. Vim thinks that escape the character in your substitute. Use separators so you don't have to escape. But I'm so confused. Trailing characters, custom command. Remove the trailing CR. It's not what I care about. Trailing characters, substitute. You don't need % as you already have another range. Oh. There we go. That looks horrible. I hate this. I did not think this was going to be a text format stream. I'm not. This wasn't the plan. But almost done, so then we can get to the fun stuff. Am I stupid? Yes. Yay! Okay. Stupid. Side quest aside, we can now apply our knowledge and make another program, Fahrenheit to Celsius, and it also gets user input. Vim f2c.zig const std is equal to import std pub fn main blah 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 const std out is equal to std.io.get std out.writer. Now we obtain the arguments. We have to allocate memory, which is an allocator. Okay. Haven't seen this yet. std heap page allocator, which is the most basic allocator. Args alloc function will use the allocator. This has the try in front of it as memory allocation may fail. So const args is equal to try cd dot process dot args alloc. So it's a type allocator and it returns a non-zero array of U8. They must call argfree dot heap dot page allocator. Is there a difference? Operating system, this allocator makes a syscall for every allocation and free. That's a type, I guess. Okay. Do we not put a defer there? That's like the whole thing of Zig. Okay. After it gives us a slice, we can iterate over this with a for capturing the values and indices. Then we use this to print all the arguments. Okay. So for args 0 arg I try std out dot print arg I and then arg. Sig run F to C. arg0 is the file name. Makes sense? That's how that works. I don't really get... Is it this that's getting the index? Like, I get that that's what that's doing, I just don't understand how that works. We want the first argument, which is provided by the user. We can provide our program more arguments via the build exe, and then we can pass arguments to run. There are two ways we can provide. Oh, zig build, and then also zig run. Okay. So if args.len is less than 2, meaning you haven't passed any number temperature thing for it to convert, we will return error. What's the difference between error and any error? Dot expected argument. And then if I is equal to 0, continue. Sure, I guess I'm gonna try doing it the zig way. I don't know, I just find this type of declaration really hard to read, which is why I prefer it like that, but I suppose it doesn't really matter. std, yep, that stays the same. So zig run, and then let's just go 10. Dash dash 10. So it should say 10. Yeah. Hello. Zig is interesting. It's kind of a weird mix of C and Rust. This is only my second day doing this. I've done up to slices in this little guide thing so far. It's kind of like a half object-oriented programming language. So there's some things that I'm not quite used to, like slices or what was another one? I don't remember. It's cool. it's a different way of thinking than what I'm used to. I'm coming from C, so it's kind of strange, but I like it. Have you tried Zig yet? Yeah, I saw it a couple of years ago, or I guess like a year and a half ago, and I was like, wow, that's cool. And then I never touched it, and then I decided I would give it a shot. Defer, probably the coolest part about, oh my god, about Zig, in my opinion. It so instead of having like, you've looked at it, so I'm sure you know what it means. But if you like in C malloc thing, uh, do stuff on thing. Um, say you had a bunch of stuff you were doing to a thing, and then you had to free thing. You might forget about the free, which is like the whole thing with C is that's why it's unsafe. Zig still has the manual memory management through allocators. However, if you put a defer, you can allocate, and then it it puts the free rate beside it, so you can like, at least for me, that makes it a lot easier to understand in my brain. And deferred runs when the thing is out of scope, so it doesn't like immediately allocate and then deallocate. So it's like half automatic garbage collection. It's pretty cool. Also, how is my audio and stuff? I've tested it and got it to what I think is good, but I haven't had anyone. Okay, cool. Thanks. Um, so my original plan was yesterday I started this from functions and I got up to runtime safety and then I was going to make a calculator. And then it was just a complete hot garbage mess. It was like 2 hours of me just not understanding anything. It wasn't very fun. I'm hoping that this little program will give me enough insight to actually make that. That's typically how I learn a language. So I do the hello world and then I make a calculator just to like get switch case and logic flow and stuff. See how that works in the language. Um, yeah. Turn our argument into a float. Standard library. This function. Da, da, da. Okay, where do we actually put that? Okay. So, provided a string, this function fails if it is provided a string which cannot be turned into a float. Makes sense. So const f is equal to cd.format.parse float 32 args1. But yeah, I would definitely give it a shot if you are like wanting to choose between C or Rust or just like getting into a lower level language. I think this is a good middle ground for learning that. C is, while it's not that hard, it does have a lot of weird rules that confuse people. And then Rust, in my opinion, just has a bit too much hand holding. So I think Zig finds a good middle ground with that. And it has quality of life stuff like hash maps and um hash maps and like vectors and stuff. So you don't have to create that on your own like you would in C. So yeah. Um, percent F is degrees FC. Yep. Scientific form, interesting. Format specifier from blank to D, decimal form. And also precision by D colon dot X. Okay. D colon dot 2. So now if we did that, 10.2 degrees F is minus 12 C. It's probably right. Let's do one I know will work. Minus 40 should be minus 40. Yeah. Okay. Yeah, okay. Let's calc.zig. Let us start the calculator. What language are you coming from? Are you like a front end web dev kind of person or a database? Maybe embedded? Elixir. I will admit I am not familiar with that. What do you make with Elixir? Previously web apps, now some research. Interesting. So is Elixir a language or a framework? I'm going to guess from the fact that you're doing research that it's a language. footage. Okay, yeah. This doesn't need to be a parse float. Base parser for format. Can I just go reader? Parse int with generic format. I guess try that. That doesn't need to be undefined. That can be switch. What's the research on, if you're allowed to say? That sounds intense. Surprisingly, I'm not really a big math person, so I don't even really know what lambda calculus is. Um, my stream, in fact, did die. Thank you for letting me know. I'll have to look at OBS after, see what happened. Yeah. Yeah. Thank you for letting me know. I think I accidentally put a hard cap for an hour at a time when I was setting up OBS. So I will have to fix that after. I really just want to know how to get a character. Parse unsigned, I guess. Function expected 3 arguments, found 0. What? What's the... So it wants a type, a buffer, and a base. Parses a string as unsigned representation in the specific base. Yeah, no, I know that, but because it's ASCII, because here, zig guide.zig. What is going on? Where am I? Okay, anyway. So it's ASCII, right? So it's just numbers. So an unsigned 8 would be 1 byte, which is 255, which is ASCII, which is why this works. So my theory is that if I get an unsigned integer, it will like automatically detect. I don't know. It hasn't talked about characters yet. I don't know why. Formatting, string, alloc print, test allocator. Oh, would you look at that? Format to and from strings. That's great, but that's not really... Don't want to just copy that. Zig. Get char from user. Read byte. You can get a stdio reader. Da da da. Da 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 da. Any read or generic. Any reader or generic. Generic reader dot read byte. See if that works. No. Expected 3 arguments, found 0. What is it? What does it want? Expected one argument. Self, so that doesn't... Type not a function. The one thing I don't like about learning a new language is that it makes me feel really stupid. Can I just go up? No. Type, that would be a U8. Is that what it wants? No. What do you mean? Parameter declared here, struct declared here. Expected type io.reader. I just want to... I just want to get a character, man. Okay. I don't think I'm gonna find what I want to find. So... I'm gonna be lazy because I kind of just want to get something done so I can move on. Is this super hacky? Yes. I will come back and fix this once I actually know how to do it properly. For now, it still doesn't work. Expected 3 arguments. What would the third argument be? Wrong one. Parse int base, right. Okay. Base 10. Member, print cheese. Expected 2 arguments, found 1. There's a lot of little stuff in Zig, like there is in every language. I'm still figuring it out. For example, your print, regardless of whether you have variables you're using or not, you have to have this thing, which is a little annoying, but I get it. Union is ignored. Try is pretty cool. It's basically automatic error catching. So instead of having to do like if x equals error catch x, then whatever, you can just put try. That's pretty cool. Invalid character. Right. Two. I have made the worst calculator in the world. Yay. It's especially bad because the instructions run after you run it with the stuff. So you don't even know if it's an error until you've run it. This is truly horrendous. But it is technically a calculator. I'm going to add if num2 is equal to 0, return error dot divide by 0. Else expected after statement. What? Oh. Does it want it here? No. Time to make another bad decision. It's going to take the denominator. It's going to be a F32. It's going to return a Boolean, I guess. Then we're just gonna yank that. If denominator, that's not what it's called. I don't actually know what I'm doing for this. I should not have this much trouble. I have made this program a few times. Um, if num2 is equal to 0, and okay, that's one thing I don't like about Zig. Like, legitimately don't like, not like something I don't understand yet. You have to do and, or, not, apparently. Um, but you have to use actual words instead of these if you want to do the logical operations. Which, while it's not really a huge deal, it just reminds me of Python, and I really don't like Python. Uh, 4. What? Yay! This is not. I promise I'm not usually this bad. Um, this is like impressive level of bad. Um, okay. Well, for now, that will have to be good enough. Let's go back to the guide and then learn some more enums. Actually, I'm gonna take a little break, get some water. I'll be back in like 5 minutes, probably. All right, I am back. Okay, I think I will read up to and inclusive of integer rules, and then I will be done for the day. So enums allow you to define types with restricted set of named values. Enums types may have specific tag types. Interesting. So ordinal values start at 0, built-in function int from enum. Okay, let's enums. So start at 0, so it's basically an array. And then is this the ordinal value? So that's going to be the actual. No, that's going to be the index. Okay. 40 down. This terrible table. Do. Ordinal value. I'm going to do that just so I know what that means. And can be accessed with the built-in function int from enum. Specified tag types. Okay. Values can be overridden with the next values starting from there. So value 2 is enum, U32, 100 is 100,000 is 1,000, million is a million. Next. So this is the overriding. Okay. So sig test, sig guide. So that should work. Yeah. Values can be overridden. Enums can be given methods. Okay. So it's so it's kind of like a class in that way. Interesting. So clubs, spades, diamonds, heart is clubs, self suit. So that's just saying, hey, use the enum that I am. And then the declared name for it. It's going to return a Boolean, and it will return self is equal to self.clubs. So, right, self is the current instance of the thing. Okay. So these should both be the same because they're both spades. Got it. Enums can also be given var and const. These act as namespace globals, unrelated and unattached to instances. These act as namespace globals. Values are unrelated and unattached to the instances. So count is equal to 0, on, off. Mode.count is equal. So this is going to fail. That's my prediction. Never mind. So okay. Structs allowing you to define data types. I can store a fixed number of no guarantees in memory order. Structs allow, yep. Okay. So vector is a struct. It has 3 F32s. We're saying this, we're not giving it a type. So it's going to be inferred to be the same type as this. And then we're saying those are the values. And then we're discarding that. Okay. Struct fields cannot be implicitly uninitialized. So this is going to fail. Yep. And then if I go dot y is equal to undefined, that should work. Yep. Okay. That's not too bad. Fields may be given default. which means even though we're only doing x and y here, since z and w have values, it shouldn't fail. I'm just gonna go yeah, okay. Easy enough. Fields may be given defaults. However, field, okay. Like enum, structs also contain functions and declarations. Structs have a unique property. When given a pointer to a struct, one level is done automatically when accessing fields. Interesting. So, what's going on here? So, stuff is a struct. Has two variables of I32. Has a function that takes a pointer, or takes the current instance as well as a pointer to the struct. Returns void. And since self is a pointer, we don't have to dereference this. Or without needing to dereference the self pointer. One level of dereferencing is done automatically when accessing fields. Okay. So then thing is going to be that thing.swap. So that should work. Yeah. So basically, it just does the first level on its own. Okay. Unions. They're anything like they are in C. This is going to be terrible. Define types that store one value of many possible typed fields. Only one field may be active at a time. Bare union types do not have a guaranteed memory layout. Bare unions cannot be used to reinterpret memory. Accessing a field in a union that is not active is detectable illegal behavior. So result is equal to a union int float bool result.int result.float. access of union field float while int is active. So why would you ever use this? Use an enum to detect which field is active. So tagged unions are unions that use an enum to detect which field is active. Payload capturing to switch the tag type. Also pointer capture. We need that. It contains captured values are immutable, but with the we can capture a pointer to the values instead of the values themselves. Which allows us to use dereferencing to mutate the original value. Okay. So what's going on here? So we have a tag enum ABC, and then we have a union of type tag where A is a U8, B is an F32, and C is a bool. Var value is equal to tagged, so that's the union. Dot B is equal to 1.5, switch the value. So dot A byte byte. Float. Bool. So how does it switch on the tag type of a union? But how does it actually know which one is active? Is it just because this is B? Like, what if I go value equals tagged dot A is equal to 2? This should fail because it's going to be 2 float while field int is active. Result dot float. Let's try that again. So union B while field A is active. Yeah, okay, so it's just the most recent access, I guess. The tag type can also be inferred. This is equivalent to the tag type above. Is the same as above. Which I think personally is way better syntax, just to have it all in one thing. But I guess if you had like a really big enum, I mean, you should probably not have big enums, but it would be better to have. Actually, no, because you have to write that out anyway. So just that makes way more sense. Void member types. Let me just do this. So void member types can have their type omitted from the syntax. Here, none is of the type void. Okay. E. So that makes sense. It's void. You don't really have to tell it what it is because it doesn't matter. Integer rules. SIG supports hex, octal, and hello? So you can do upper or lowercase hex, it doesn't matter. Um, you can also put underscores between digits. I don't really think. I guess for hex and binary, that would be good. Integer widening, which means an integer may coerce to an integer of another type, providing it can fit all the values the old type can. So turning a U8 to a U16. Yeah. is pretty self-explanatory. So if this was like a R4, that would not work, because 4 binary digits cannot fit 250. They can only fit 16. But 16 does because it's bigger. That makes sense. If you have a value stored that cannot coerce to the type that you want, int cast may be used to explicitly convert from one type to another. If the value given is out of range, this is detectable. Okay. An integer value that cannot coerce to the type that you want. Maybe explicitly converted by using, nope. Converted by using int cast. If the value given is out of the range, this is detectable illegal behavior. Yeah. So we're taking a U64, and then as a U8, we're going to int cast. So that should work. 8 can fit 200. Yep. And then integers are not allowed to overflow detectable illegal behavior. Integers by default are not allowed to overflow. And this is detectable illegal behavior. Sometimes being able to is wanted behavior. For this use case, SIG provides overflow operators. Time to die trying to make another table. Did I figure out reading the operation? No. I did something really stupid. I'll show you in a moment when I finish this. So I have no idea when you would ever want to overflow, but apparently that's a thing you're allowed to do. I guess error checking? So what I did for the operation for now, I'm gonna fix this later, was basically just I made it a number and you pick the number. So for example, zig run calc. So if we wanted to do 1 plus 2, that would be 1, 1, 2. It's really horrible for a multitude of reasons. Written in BASIC. Yeah. I feel like for BASIC, that's like understandable though, because it's, BASIC. Did it have, I mean, I'm sure it had like string operations and user input, but I imagine that would be like quite complex for BASIC, just based on what I know about it, which admittedly is not a lot. The thing that really gets me for this is you have to run the program first to see what the options are, which I think is just like funny bad. But yeah, that's just temporary. I'm gonna make it actually nice once I figure out how. It was just gonna really bother me if I couldn't make something. Um, and it also does divide by 0 checks. So, yeah. Technically, my first real program in Zig. It just happens to be awful. Yeah. I'm also working on a project in C at the moment that I'm taking a little break from, which is a little more advanced. It's a network file share program, kind of like FTP, except it only works on the LAN. Um, so coming from that to not being able to make a calculator is a little frustrating, but yeah, gotta start somewhere. If you're curious about that file share program, on my Twitch thing, I have my GitHub, and it will be in projects, file share, and then this is all the source code for it, as well as the make file to make it and a compiled version. Um, kind of sucks right now. It's not done. Don't use it. But yeah, lots of stuff I want to add to it. Just need a break from it because I've been working on it for a couple months now. It's the only thing I've been working on. I was getting a little burnt out. But yeah, coming from that to, oh, how do I make a calculator? It's kind of funny. Um, yeah. One second. Okay. I forgot to put my mic here. I think with that, I am going to be done for the day. Thank you for showing up. Um, I promise I'm not always gonna make terrible programs. Uh, but yeah, I will see you next time.